Hello, this is chapter 3. We've got some testing code now doing sending. Now it's time to turn our attention to receiving. At this point, you should have got a project called message testing in your workspace. Let's write some receiving code. And although we could do that in this application, I think it makes more sense and it should be clearer if we do this in a separate project. I think the quickest way to do that, given that the dependencies for the receiving project will be identical to the dependencies that we've got on the sending side, I'm going to take a copy of this project. And I don't know if you know this, but in Eclipse, you can right click and do a paste, and it will effectively create a new project for you. I wish I'd not called the first one message testing. I wish I'd called it sending. For this one, then, this is going to be receive testing. And just to make sure that I don't do anything silly, I don't work with files from the wrong project, I'm going to temporarily at least close the first project. So now we're on the receive testing project, and a quick check of the POM. We've got that resource filtering going on in there, and we've got the same active MQ dependency, so that's good. I guess we ought to change the artifact ID here. It doesn't really matter. I'm not going to publish this into a Maven repository, but nonetheless, it really probably should be done. And okay, we'll do the name here as well. Now, of course, we've got the application.properties here, which will have the same queue URL, which is exactly what we want. But of course, the code is going to be different, and we'll remove the convert and send line. How do we receive? Well, you could probably pause the video now and have a little play for yourself. You're going to find, with very little effort, that there is a message in there called receive. Well, there's actually two variants. It's a little bit like on the sending side. First of all, we'll need to call the version with a destination name because we haven't set a default. But we've got receive and we've got receive and convert. The difference? Receive is going to give you a raw JMS message. Let's have a look at using that first of all. So we know that the queue is called position queue, and it's going to return us an object of type message. Now, if we import that, I bet that's going to be an ambiguous import. It is. Now, be careful here. Don't think we really want the ActiveMQ one because we're working here with the standard API, JavaX or javax.jms. Now, the problem is I want to print out the textual content of that message. We know it's a text message, but this message is actually an interface and it represents all of the different types of messages. And not all messages have text bodies. So we've got map messages that have key value pairs and so on. So it's an awkward aspect of the JMS API that we have to kind of know what the type of incoming message is going to be. Now, that might sound bad, but it's not really a problem in practice because generally speaking, when you've set up a queue, it has a very specific purpose and you only ever send one type of message to that queue. But we've got other ways around this anyway, but I'm just going to do a typecast here. I've done this quite long-windedly. You can improve the Java on this. But if I cast it to the type that we know it is a text message, and that will need to be imported. This time there's only one, javax.jms. And now we should be able to call the getText method on that object. And of course, I'm just doing a system out print line. We have a compile error, and this is another ugly corner of the JMS API that many, probably all of the methods you can call in JMS might throw a checked exception called JMS exception. Now I'm going to show you a better way of doing this in a minute, so I'm going to do the quick and dirty thing of just adding the throws declaration to the main method. Okay, now I know that would get me sacked on a lot of projects, but it will work just fine for this test. Now I haven't explained yet what's going to happen with the receive method. Is it going to give us multiple messages or just one message? What happens if there are no messages on the queue? Well, I suggest we just give it a run and try. Before then, it's worth reviewing what we do have on the queue. We currently have 3 messages on the queue. You might have a different number. just make sure you've got at least one message on that queue. Now, before running this, I've been a little bit sloppy in the way I've set up these projects, and I just did a copy there. Now, I think what we will have done is we will have copied the exact class path of the previous project, and that will be pointing to my Maven repository, which is a hidden folder somewhere on my hard drive. So I should be okay in terms of libraries and jars and so on. If you feel nervous, you might want to run Eclipse again, possibly do project clean. But I think we're going to be okay to run this. So let's see what happens. It's buried in the logging a little bit, but can you see there that I am indeed seeing the string contents of one of my messages? And again, the container is being correctly closed. But it was only one of those messages received. If I go now to the queue here and do a refresh, we've now dropped down to 2 messages, because when we do a receive, the message is consumed from the queue. Now, unlike some other message brokers, we don't have to manually delete the message once we've received it. And that's the way JMS works. The assumption is once you've received a message, it has been successfully handled. So more on that shortly. I'm going to run this a couple more times then and get the other messages from the queue. By the way, a common question here is, in what order do the messages come off the queue? And the answer in JMS is always, we don't know. There's no guaranteed order of delivery of messages. So bear that in mind. Clearly, each time I run this, it's plucking one message from the queue at a time. But now we're down to an empty queue. I wonder what happens if we run again. Big difference this time. Program's still running. Clearly, it's waiting. And I can tell you now, you just need to check the Java docs for this. It is going to wait indefinitely with no timeout. So if I now send a message to that queue, you can do that using your Java code in another window. Or, of course, we can go to the ActiveMQ console, find the queue, and we will send something to it. And did you see there, pretty much instantaneously, as soon as I sent that message, it was successfully received by my code and the program finished. So how did I know then that that was going to wait indefinitely? Well, there is a property on the JMS template which we can get called getReceiveTimeout. You can see that returns a long. It's going to be a millisecond value. And that tells us how long the timeout is going to be. How long will it wait if there are no messages in the queue? Now, I'm just going to do a quick sysout on that. And I'll run again. And from the logging here, you can see that the default value is 0, which obviously doesn't mean 0 seconds. It means, or milliseconds, it means an infinitely long timeout. By the way, we have a bit of a problem here, because if we are in an infinite timeout and we're never going to receive a message, we will have to hit the stop button to terminate, in which case the application context has not been automatically shut down because we've done a violent crash out of the program. So I'm not going to worry about that for this testing application. If you're going to do this indefinite wait, then you need to be pretty careful to make sure that you can somehow shut the program down correctly. Of course, we can set that timeout. That should be pretty simple with a set method on the template. Set receive timeout. Let's try 1,000 milliseconds for 1 second. And I won't do any editing here. Well, there was a pause there, but I had a crash. You might be surprised there's an exception there, but it wasn't thrown by the receive method. In fact, what happens is, if this times out, then we'll get a null back for the message. So your code would have to deal with that appropriately. Anyway, I'm not going to bother with receive timeouts because I'm going to show you a much better way of receiving messages in a minute. But just before I do that, it's worth mentioning that I went there for the sort of very basic version of receive, which returns as a raw JMS message. But just like we did on the sending side, we can use an alternative method called receive and convert. And this really does the opposite of convert and send on the other project that we've done. That will inspect the type of message that it receives, and it will automatically attempt to convert it into the correct type. Now, because we know this is going to be a string, we could declare that as a string. Well, we would have to do either a cast there to string, or alternatively, we could just do to string. And that improves the code quite a bit because we don't have to do this separate cast, and we don't need to call a get text because that will be automatically converted. And the best bit there is we don't need to throw that JMS exception anymore. That's all being handled by the JMS template. So I can do a Control or Command Shift O there to clean up the imports. Now if we run again, bear in mind now my timeout is indefinite. So I can, at my leisure now, send a message. And there you can see the automatic conversion is working. So this is okay, but the problem with doing this kind of receiving and blocking indefinitely and plugging in timeouts is, of course, we're going to be receiving lots of messages over time. We don't just want the program to end. So you could, I guess, go ahead and put in some kind of infinite loop here with maybe a delay in the middle, but there is a much better way. If you've worked in Java EE at all, then you will be familiar with the concept of a message-driven bean. And it's a really wonderful concept where you simply create a class, a standalone class, with a method. And it's a callback method. And you set things up so that every time a message is received on the queue, automatically that callback method will run. Well, for years now, Spring has had the same concept. It's called an MDP. We'll put a caption up for that because my pronunciation might not be perfect. It's the direct analogy of a Java EE message-driven bean. They're dead easy to set up. Let me show you how to do that now. And this has probably got to be one of my favorite parts of working in Spring Boot. This is a joy to work with. Let's back off on the work we've done so far. We'll return the whole of this class back to as it was, just running the Spring application, and I can tidy up the imports. And I'm going to go ahead now and create a brand new class, which I'm going to call my message receiver. I think I'm even going to call it MDP. Now, I think MDP is a bit of a term that seems to have fallen out of fashion in Spring circles these days. Maybe because they don't want to be associated with Java EE. I don't know. But I'm going to call it that just for illustration, I guess. And if you're expecting anything heavy here, it's really simple. This is going to be a regular Spring bean. We want it to appear in the container. So we're going to add the @component annotation. Depending on your requirements, I guess you could put an @service annotation on that, maybe if you want to do transactions and that kind of thing, but I'm happy to go with a component for now. And we just write a method, and it can have any name we want. So I'm going to call it process message, but you can feel free to change that if you want. The only restriction here is we do have to be quite precise with our input parameter. And it's a simple case of, depending on what type of message we're expecting to receive, we can declare the parameters accordingly. If we might be dealing with different types of message, then this would be an object, and we would have to do some intelligent casting here inside the implementation. But we know at the minute that this is always going to be a text message. So if I declare a string object, which I'll call message, then again, that's going to automatically do a receive and convert before this method even runs. And then inside here is just going to be my processing code, which for now is just going to be a simple system.out.println. Well, it can't be as simple as that, and it isn't. We just need one annotation on here to make this a listener, a message listener. And the annotation is @JMS listener. Be careful here, there are two of them. It's the singular version that we need, JMS listener. And then this one takes parameters. There's a collection of parameters there, but the one we need to add in is the destination, which is going to be the name of the queue. Position queue. I still can't quite believe this, but that's it. We are finished. If we now run the application, there will be a big difference. We haven't written any loops or anything, but the fact that we've now, and I guess you know Spring Boot well enough to know that the fact that we've got app components on here and it's in a sub package of our root package means that automatically this bean will have been picked up by automatic component scanning. So there's now an object of this type in the container. The JMS listener means that Spring knows a daemon thread is going to be needed. And that's the key thing here. Notice that the code is still running and it will continue running indefinitely. But it's not blocked. This is a callback mechanism. And I can now, however I want, I'm going to do it through the console first of all. We can send a message to this queue. And there the callback ran. Of course, before long, that's going to be really interesting business logic. Now, it's not very elegant, this, because I've got both the sender and receiver on the same workspace. When we do the practical work, we're going to maintain separate workspaces for these projects because we want separate workspaces for microservices. Hey, it'll be okay for now. If we open up this old message testing project, and we'll run the main application in there. We've now got two console windows laid on top of each other. And you probably know you can switch that using the icon here. So here's the receiver, and there's the message successfully received, which is great. So what I love about this is that all the components are there for a professional scale messaging application. Of course, you can go deeper than this. And I will invite you now to check out the reference manual if you want to go any further. But for me, this is all the tools we need to start implementing our microservice-based architecture. Before we wrap up, I want to have a look at one of the aspects of the JMS system, which I think is so important when it comes to microservices. And so if you already know about this, you can safely skip the rest of this chapter. We'll be doing the practical work in the next chapter. But for those of you who've not come across this before, one of the main aims of JMS is that using its defaults, although you can switch this off if you want, using its defaults, the aim is what we want to have is every message successfully consumed, even if things go down, even if things are unavailable. So you've already seen that if the queue goes down, when it comes back up, by default, all of the messages we've sent through the code are persistent. So they will be read back from disk. So that's one way of not losing messages. But another way, and this is so important for microservices, think about the impact of this, is that if there is a crash in here, this is my message processing. I want you just to imagine for now that there's a very long process going on in here. Actually, as a designer, we probably want to get the processing in here down to as short as possible so that we don't have the queue blocking up and getting long lists of messages. For this illustration, this will be useful. Imagine there's a long process in here, and this system out print line is the end result. But for some reason, in the middle of here, there's a crash. Now, I want to be careful about what I mean by a crash. I don't mean that there's something wrong with our code, because we wouldn't have deployed our code to production if there was something wrong with it. It's not an error in our processing. It's an error due to some external reason, some environmental reason that we can't control. It might only happen for 2 seconds every year, but it can happen. Now, on our original JMS course that I released years ago now, I came up with a story that we were calling a third-party unreliable system that crashes half of the time. Perhaps a slightly contrived example, but I think that is a use case that has a lot of applications. In microservices, there is a very specific reason why suddenly, in the middle of doing this work, we might get a crash. And I'm going to suggest that could be a redeployment. Because these microservices are small, we typically need to redeploy them constantly in production. And we need to be able to redeploy them without that redeployment having an effect on other microservices that depend upon it. So imagine if that we're in the middle of this long process and we start to redeploy this microservice. Well, we're not going to get an exception as such, but the power's just going to go off. I can always simulate that. I realize this is a bit cheesy, but I always do it like this. I just throw a runtime exception. Null pointer exception, whatever. But it's going to stop dead in the middle of that processing. Java's being too helpful here because it knows this line of code is now unreachable. But okay, I can be even cleverer here. I can put an if statement around that. If 0 equals 0, then we know that's always going to throw the exception. The Java compiler, interestingly, does give us a warning that this is dead code, but it doesn't give a compile error anymore. So I've kind of tricked it into compiling it, but we know it's going to throw this exception. The point of doing this is that what will happen is the message will not be lost. This is crucial. Because there's been a hiccup here, then the message will be requeued. And that means that since this is only a very temporary problem, we hope that within the next few minutes at least, this microservice will be back in action again. Once the microservice is back in action, well, it can pick that same message up again and start the processing again. So, of course, a very unrealistic block of code here, but I hope it's illustrating the concepts adequately. Let's give this a try. Make sure that you've terminated the previous run, and we'll start this up again. I've just realized I forgot to do this. On the receive testing project, I didn't rename the main class, and I think it would be well worth doing that for clarity. So I'll do a refactor and rename, and we'll make this the receive application. We'll get a warning there, but we can ignore that and finish. So it's the receive application that I want to start again, and that's going to sit there now, waiting for a message to come in. Now let's have a look at what's going to happen if I try to send a message to that queue. And my question is, will this ever get processed? Or will it get lost? Oh, actually, before I run it, we really should put in probably another system out print line so we can see that we are attempting to process a message. And I think I'll put this throw into a block and another sys out in here to say that we've crashed. Okay, that's a bit better. So now I'm going to send it a message, and it's important that we send the message from our code and not through the console. I'll explain why that's the case in a short while. So we go to our message testing app and run the message testing application. Now watch the console very carefully on the receiving side, and you can see I'm getting a horrible number of exceptions. Now what's happening here, I don't know if you expected this, but when we get the crash, the message is going straight back onto the queue, which is then getting picked up here. It's being processed again. The crash happens again. It goes back on the queue. We go back to the beginning. We keep reattempting. Now, although this reattempting is a great thing, it's a very powerful feature. It's only useful if somehow the problem goes away at some point in the future. Now, that's never going to happen here, and we do not want an infinite loop. So what happens is very clever. You can count how many times this stack trace has happened. It looks like about 6 times, but it's actually stopped doing it now. And that's because if we go back to the console here and do a refresh, I don't know if you've noticed this queue here, which I've sort of been ignoring since the start of this chapter, but you should have an extra queue called activemq.dlq. This is an acronym for the dead letter queue. Now, what happens is, if a message is re-queued more than a certain threshold, more than a certain number of times, the broker thinks, there may be something wrong with this message. So it takes that message and it pops it onto just really, you can think of it as being a little bit like a trash can. It's a destination specifically for, they're sometimes called dead message queues, but here it's called a DL queue. If we have a look at the contents there, yeah, you can see we've got a message there. Now, this is what a system administrator might do, or a DevOps person might do. They might check the health of the system by making sure that the dead letter queue is empty regularly. And if they do find a message in there, they'll have a look in here and they will get a clue as to the cause. Now, what we have here is the default settings for ActiveMQ. It said that it tried to deliver 6 times, and the delay for each of those deliveries was 1,000 milliseconds each time. Now, they're just the default settings, but I'm here on the ActiveMQ reference manual under redelivery policy, and we have here a list of those properties that we've just seen in the message with their default values. Again, we've already observed those default values, but of course, we can change these defaults, and as stated here, we can use either Java code, Spring, or something called the connection configuration URI to customize this. Now, I'll let you look into the details of all of these various different ways, but for me, the easiest that I'm going to show you is to simply change the URL of the broker that we're connecting to. If I go back into my project, and you will definitely want to stop the receiving application, and we're going to go to the application.properties for the receiver. Now, that might not have been entirely obvious, but it's on the receiving side where this redelivery policy is going to be applied. And what we can do here, again, I'm just working from the manual, we can supply a query parameter into this URL. So we just have a question mark, and then we have JMS.redelivery policy. Be careful to spell that correctly. I'm always making a typo there. And then a dot, and then any of the properties listed here on the ActiveMQ manual. By the way, I should say that these settings are specifically for ActiveMQ. If you have a different broker, then the settings will be different, and the mechanism for making the settings will be different, and your broker might not even support these features. So that's definitely one reason why you would choose one broker over another, whether or not it has this feature. So I can pick, for example, let's change the maximum number of redeliveries to, for reasons that will be obvious in a second, I'm going to lower that to 3. But I'm also going to include, and we'll need an ampersand here, JMS.redelivery policy again. And for me, the most useful property is the use exponential backoff. And this is excellent. It's false by default, but if we set this to true, it will use this backoff multiplier, which is by default 5. On each redelivery, it will increase the redelivery delay by a factor of, in this case, 5. So the second redelivery will be after 5 seconds, then it will be after 25 seconds, and so on. And this is great because it just prevents us from thrashing the queue and very quickly turning the messages into dead messages. If the system's undergoing some kind of redeployment, then we sort of just want to slow down and back off and give the system time to recover. So I'm going to set use exponential backoff to true. And as I say, with a much bigger number of maximum redeliveries here, we'd have quite a long time for recovery. Now I'm using 3 here for the demonstration just because I do want to see the message go onto the dead letter queue so that we can make sure everything's worked okay. So that's the only change we need to make. We can now run the receiver again and check for any typos here if you see an exception in the console. But now we can go back to the sending application. Now I can tell you now the reason that we need to send this message using the code is if we send the message using the console, then that message will be not persistent, and non-persistent messages are not sent to the dead letter queue. So I just wanted to send through code so we can see the DLQ in action. So let's send a message. Now I did do some editing on the video there because there was a time delay, but I can prove that this is working because the first processing of the message was at 3 seconds. The second attempt of processing the message was at 4 seconds. That's 1 second later. And then there was another redelivery here at 9 seconds. That's 5 seconds after the previous one. And then a final attempt was made. So that was 3 reattempts. And that's at 34 seconds. In other words, 25 seconds later. Since that's the final attempt, go back to the queue list now. We should find a message on the dead letter queue. And if you check these properties here, maximum redelivery is 3 and use exponential backoff true. So these are some good properties to start with. You may need to tune these in production. And that's definitely something you'll need to think about quite hard. But for now, at least, I think this is a good set of settings to prevent any problems if we experience a very temporary downtime. And by the way, in the case of a redeployment, it would just be, we go into the MDP, it would just be here once at the point of redeployment that the message is requeued. Then, of course, there would be a delay whilst the new version of this MDP is deployed. And then we would assume that really on the first redelivery, everything should go through okay. So perhaps the redeploy example wasn't the best one to use. It's possible that it might happen, but it is something of an edge case. But we're about to start moving towards a microservice architecture, and it's absolutely possible that this message handler might need to call another microservice to do its work. And that might be a synchronous call to a REST endpoints. And of course, there's every chance that this so-called downstream microservice could be temporarily down, maybe because it's redeploying. Well, I hope you can see now that the beauty of this mechanism is that with this exponential backoff and maybe a slightly higher number of retries, this is a nice way of giving the downstream service time to come back online. It is a bit of a tuning thing. The downside of using exponential backup with a higher number of retries is if you do get a poison message on the queue, then it's going to take a long time for that poison message to be finally sent to the dead letter queue. And whilst that poison message is being consumed, there will be other messages in the queue all backing up. So it's something that you might have to consider when you're deploying this. So that's really where the rest of this course is headed. We're going to be using this and some of the Netflix components to help us decouple the various microservices so that the death of one microservice doesn't cause the death of all the others. Now, I think I'll get rid of this code because, of course, it's not very useful to do things like that. And I'm going to stop and restart my receiver. What a system administrator could do at this point, now that they see that the root cause of this dead letter has been fixed, we can always come down to here and we can move it to the position queue. So we select position queue from the drop down, click on move. Are we sure? Yes. It's now gone to the right place, and we would hope. And yes, there it is. It's been consumed. So that's all the theory in place. What we need to do now is to actually implement this and see how it can help us build decoupled microservices. Rejoin me in the next chapter and I'll give you some requirements and you can get off and do some code.